Trigonometry can be a scary word sometimes, but it won't be too bad on the SAT once you know a magic word. No, not abracadabra. Our magic word for right triangle trigonometry is Sohcahtoa. And no, it's not really a magic word, but it is a mnemonic for remembering how to use your right triangle trig functions. The three main trig functions you will need to know for the SAT are sine, cosine, and tangent. Sohcahtoa can help you remember how to use them. The S in Sohcahtoa stands for sine, the C stands for cosine, and the T stands for tangent. But make sure to only use Sohcahtoa with right triangles. Okay, so Sohcahtoa has three parts corresponding with three trig functions. That's great, but what do we do with it? Sohcahtoa gives us directions on how to determine sine, cosine, and tangent. So stands for sine equals opposite over hypotenuse. If you have a right triangle, the sine of an angle equals the length of the side opposite that angle over the hypotenuse. You'll remember that the hypotenuse is always the side opposite the 90-degree angle. So, if sine equals opposite over hypotenuse, what is the sine of theta in this triangle? Theta is the Greek letter that mathematicians often use to stand in for the measure of an unknown angle. Okay, back to the question. We'll start by writing out our formula to help minimize the chances of making a careless mistake. Now, let's find the side opposite the angle. In this case, that is 5, so we'll drop that into our formula, and then we'll find the length of the hypotenuse. The hypotenuse is 13, which we'll fill in here. So the sine of angle theta will equal 5 over 13. The next part of our magic word is ca, which stands for cosine equals adjacent over hypotenuse. If you have a right triangle, the cosine of an angle equals the length of the side adjacent to that angle over the hypotenuse. So if cosine equals adjacent over hypotenuse, what is the cosine of theta in this triangle? We'll start by writing out our formula. Then we'll look for the side adjacent to the angle. In this case, it's 12, so let's fill that in here. Now we need to find the length of the hypotenuse, 13, which we'll fill in here. So in this right triangle, the cosine of angle theta will equal 12 over 13. All right, we've done a lot of trig, but we have a little more ground to cover. Let's talk about the last part of our magic word, toa. Toa means tangent equals opposite over adjacent. If you have a right triangle, the tangent of an angle equals the length of the side opposite to that angle over the length of the adjacent side. So if tangent equals opposite over adjacent, what is the tangent of theta in this triangle? Once again, to minimize our chance of making careless mistakes, we'll start by writing out our formula. Now let's check out the side opposite the angle. It's 5, so we'll put that into our formula. Next, we need to find the length of the adjacent side. It's 12, which we'll drop into the formula right here. So in this case, the tangent of angle theta will equal 5 over 12. And what if we wanted the tangent of this angle? Well, then the 12 becomes the opposite side, and the 5 becomes the adjacent side. So the tangent will be 12 over 5. One quick reminder, you can only use Sohcahtoa on right triangles. Now that we know what Sohcahtoa means and how to work with it, it's time for a practice question. Given that sine of 42 degrees equals 0.66913, cosine of 42 degrees equals 0.74314, and tangent of 42 degrees equals 0.90040 in the figure below, what is the length of AC to the nearest hundredth? Our answer choices are A, 6.66, B, 7.43, C, 8.07, and D, 8.97. Let's start by underlining the facts, circling the keywords, and labeling the answer choices. Now let's take a look at the picture. The first thing we see is that this is a right triangle, so we can apply Sohcahtoa. We're looking to find AC, which is the hypotenuse. We know that this angle is 42 degrees, and we know its adjacent side is 6, so we should be thinking cosine, which, from our Sohcahtoa trick, we know is adjacent over hypotenuse. Now let's start filling in the stuff we know. The angle we're using is 42 degrees, the adjacent side is 6, and we're looking to solve for hypotenuse AC. So now we have an equation we can use to find AC. Next, if we look at the top of the question, we can see it tells us that the cosine of 42 degrees equals 0.74314. So in our equation, let's replace cosine of 42 degrees with 0.74314. Now we need to get AC on its own. So let's multiply both sides by AC and then divide both sides by 0.74314. So AC equals 6 divided by 0.74314. Let's check that on our calculator. We get AC equals 8.073848. The question asks us for our answer to the nearest hundredth. So we've got 8.07, which is answer choice C. Great work. When you've got your Sohcahtoa down, SAT trigonometry questions get a lot easier. And that brings me to another magic word you can use to improve your score: practice. We've got hundreds of practice questions in the course, so go and do at least a couple of them.